Today we're going to be learning about multiplication and how we can represent multiplication problems using arrays. We're also going to talk about the relationship between division and multiplication problems using fact families. Multiplication is another way for us to represent repeated addition. For example, here we have 4 pieces of candy. However, what if we put those candy pieces in a bag and then we add another bag full of candy? We would simply add 4 plus 4. But if we throw another bag of candy into the mix, the addition problem could get quite long. 4 plus 4 plus 4 equals 12. We use multiplication to simplify this process. Here we have 4 pieces of candy, but we have 3 bags of 4, giving us 4 times 3, which equals 12. A multiplication problem is made up of factors that are multiplied by each other to get to your answer of the multiplication problem, which is called the product. In multiplication, we use something called an array to represent the multiplication problem. An array is a picture that shows a set of equal groups in rows and columns. So here we have 4 columns and we have 3 rows. So this represents the multiplication problem, 4 times 3, which equals 12. I should also be able to count my answer. If I were to count each of these items in the rows, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here is another example. Here I have 2 columns, 1, 2, and 1, 2, 3, 4, 5 rows. You could say you have 2 columns of 5 or 5 rows of 2. Either way, that's giving you the multiplication problem 5 times 2 equals 10. You won't always see arrays being created using pictures. Sometimes you'll see them drawn on graph paper, such as this. I still have columns and rows. Here I have 1, 2, 3, 4, 5, 6, 7, 8 columns, and 1, 2, 3 rows. Therefore, this picture, or this array, represents the multiplication problem 3 times 8, which equals a product of 24. Because multiplication and addition problems both have the commutative property, we know that 3 times 8 will also have the same product as 8 times 3. It doesn't matter which order the problem is labeled. So this array could also represent the multiplication problem 8 times 3. It's not specific to whether or not you are identifying the columns first or the rows first. Therefore, down here at the bottom, I have drawn the multiplication problem 2 times 4 two different ways. Either of them could be used to represent the multiplication problem 2 times 4 equals 8 or 4 times 2 equals 8. Sometimes you will see arrays drawn using dots, such as this. I still have my columns, 1, 2, 3, 4, 5, 6, and I still have my rows, 1, 2, 3. Therefore, giving me the array that represents the problem, 3 times 6 equals 18, or 6 times 3 equals 18. Sometimes you will be given the product first and then asked to identify the number of factor pairs that you can use to create that product. For example, here I have 3 different pictures and each of them represents an array. However, when you add them together, you can count. So if I counted each of the dots in this picture, I would have 24 dots. Count each of the dots in this picture, I have 24 dots. And if I count each of the dots in this picture, I have 24 dots. However, each one of these arrays is representing a different multiplication problem, but it's representing a multiplication problem that all will have the product of 24. So for example, here in this problem, I have 3 rows of 8, giving me the problem 3 times 8 equals 24, or 8 times 3 equals 24. Down here, I have 4 rows of 6, giving me the problem 6 times 4 equals 24, or 4 times 6 equals 24. And over here, I have 2 rows of 12, giving me the problem 2 times 12 equals 24, or 12 times 2 equals 24. We can also use fact families to represent our understanding of multiplication, especially how it relates to its opposite operation of division. We have 4 operations: addition, subtraction, multiplication, and division. Addition and subtraction are opposite operations, and multiplication and division are opposite operations. We're going to use those in our fact families. Based on what we just learned about arrays, as well as our understanding of the commutative property, we know that this array can represent the multiplication problem 3 times 6 equals 18 and 6 times 3 equals 18. However, we can also see this array from a different perspective. If we were to think of it from the opposite operation, the division operation. So instead of starting with the pieces, what if we started with the whole? Here we have 18 dots, and instead of multiplying them, I'm going to think of how could I divide these up into equal groups. So if I start with 18 dots and I want to see how many equal groups of 6 I can get out of 18, and I divide this up so that I have 6 in each of these circles, I now know that I can get 3 groups of 6 out of 18. I could also divide it up and see how many groups of 3 I could get out of 18. So instead of dividing the rows, I could divide the columns, and I would know that I would be able to get 6 groups of 3 out of 8. This gives me my completed fact family, or all of the combinations of multiplication and division problems I can create using the numbers 3, 6, and 18. Pause the video and write the fact family that is represented by this array in your journal notes. Remember, there will be 4 parts to your fact family: 2 multiplication problems and 2 division problems. When you're ready to check your answer, resume the video. You should have included 3 times 4 equals 12, 4 times 3 equals 12, 12 divided by 4 equals 3, and 12 divided by 3 equals 4. Pause the video and draw an array to represent this fact family in your journal notes. You could draw a grid, dots, or pictures. Once you're ready to check your answer, resume the video. Hopefully your drawing looks similar to this, although you could have been much more creative than I was. In any case, you should have at least 4 columns of 5 or 5 columns of 4. Either way, as long as you have 4 and 5, or a combination of 4 and 5, and a total of 20, then your answer would be correct. In this video, we learned about multiplication and the way that we can represent multiplication problems using arrays and fact families.